Okay, in this video 5.5.3, we're going to solve trigonometric equations using identities. So not only will you want your unit circle handy, you'll want your formula sheet handy, because we're going to be needing that in order to solve these equations. So our first example, 2 cosine squared of x plus 3 sine of x equals 0, and of course this is only between 0 and 2 pi, so you don't have to give all solutions. Now, if I take a look at this, number one, I see quadratic, I see a squared, and I also see cosine and sine. I don't see any factoring I can do. So in example 4 from the previous video, you did some factoring. You took tangent of x out, and you could use the zero product property. But here I cannot do that because there's nothing in common they have. No sine or cosine that is what I need to pull out. So what I'm going to do is use an identity. I know I can replace cosine squared of x with something that has to do with sine, which will lead me into factoring. So I'm going to replace cosine squared of x with 1 minus sine squared of x. Okay, then this will start to look more like example 3, if you remember that one from the second video. Plus 3 sine of x, okay, equals 0. So now I need to just work this out and simplify. 2 sine squared of x plus 3 sine of x equals 0. So now I'm going to factor just like we did in the previous video. So now I see remember, think of sine of x as a y. So I see y squared, I see a y. It's all equal to 0. And I can factor. So I'm going to use my generic rectangle to help me see. This is negative 2y squared. Positive 2 goes in this corner. And I have a positive 3y. So I'm going to use my diamond problem to help me solve this. I want the sum to be 3y. That's the sum of these two corners needs to be 3y. And then I want the product to equal the product that I see here. So the product should be negative 4y squared. So what multiplies to negative 4y squared but adds to 3y? Well, let's see, it has to be negative and a positive. Negative 1y and positive 4y. So those are my two corners that I was missing in my generic rectangle. So in these corners here, negative 1y and 4y. So remember, from this point on, we simply use logic to help us figure this out. Let's see, 2y and 2, because that's 4y, and then negative 1 and 1. Of course, that's a y there. Let's see. Now we're going to write it as a product. So we have the product from my previous sum is going to be replaced with 2y plus 1 times negative y plus 2 equals 0. But of course, remember earlier we replaced y with sine of x, or sine of x with y. So we're going to go back and replace that again here. So we're going to have 2 sine of x plus 1 times negative sine of x plus 2 equals 0. And now I'm going to solve these two functions for when are they 0. So when is 2 sine of x equal plus 1 equal to 0? Subtracting 1 from both sides, I get 2 sine of x equals negative 1. Dividing by 2 on each side, I get sine of x equals negative 1/2. Now I turn to my unit circle because I need to find the angles where sine is negative 1/2. And I see those angles are, when sine is negative 1/2, that's the y. I see it here, and I see it here. So my two solutions are 11 pi over 6 and 7 pi over 6 for this half of the quadratic. 11 pi over 6 and 7 pi over 6. Okay, so now I'm going to take a look at the other half of the equation. When is negative sine of x plus 2 equal to 0? So negative sine of x plus 2 equals 0. I subtract 2 from both sides. Negative sine of x equals negative 2. So the question is really asking, when is sine of x equal to 2? And I know that is never equal to 2, because once again, sine can never be greater than 1 or less than negative 1. So it doesn't fall in the range of that function. So this is never true. So this side of the equation will never equal 0. Therefore, these are my only two solutions that I have over here. So I am done with this problem. So let's review. We went and took and replaced cosine squared of x with this term that had to do with sine squared of x. So we're going to be using our identities. So you have to keep an eye out for when you can combine things and change things. Let's take a look at the next example. The next example has cosine 2x plus 3 sine of x minus 2 equals 0. So once again, I have two different terms. I also have two different angle values. I have 2x and I have x. So I have an option. I can either move that up to 2x or I can drop that down to a single x. I know from my formula sheet that cosine 2x has 3 formulas, and there's one formula that involves sine. So that's the formula I'm going to use here. I'm going to use the formula that states, that cosine 2 of x is equal to 1 minus 2 sine squared of x. So immediately I'm going to have my sine squared of x in my equation, dropping everything else down, plus 3 sine of x minus 2. So this first part was equal to cosine 2 of x. So I replaced it using an identity. So now let me see, I'm going to simplify this out a little bit. I get negative 2 sine squared of x plus 3 sine of x minus 1. Once again, I'm going to use my quadratic understandings to help me. I'm going to change the sine of x out for y. So we're going to let y equal sine of x. Well, of course, this is all equal to 0. I don't want to forget that part. And I have the following equation that I'm going to work with. And I'm going to use a generic rectangle. So negative 2y squared and negative 1 go here. So it looks like my diamond problem will be what adds to 3y. But I want it to multiply to, let's see, the product here is 2y squared. Adds to 3y, multiplies to 2y squared. And so I get the, let's see, adds to 3y, 2y and y. That multiplies 2y squared and adds to 3y. So in my corners I have 2y and y. And it looks like, let's see, this has to be the 2. And this has to be y. It looks like everything might have to be negative. Because, well, one of these has to be negative. Negative, and then this would have to be negative 1 and positive 1. There we go. So we have our equation is rewritten as 2y minus 1 and negative y plus 1 equals 0. Now I'm going to go back to sines and cosines. Okay, so let's take a look and let's go back to sine of x. So I'm going to go back and replace all my y's with sine of x. So I have 2 sine of x minus 1 as one factor, and the other one is negative sine of x plus 1 equals 0. Now I'm going to figure out when these two equations can equal 0. So when is 2 sine of x minus 1 equals 0, and when does negative sine of x plus 1 equals 0? Okay, so adding 1 to both sides, I get 2 sine of x equals 1, or sine of x equals 1/2. So when is sine of x equal to 1/2? Well, that's in the quadrants 1 and 2, so it looks like it's here and it's here. So my two solutions are 5 pi over 6 and pi over 6 for this half. The other side, I'm going to subtract 1 from both sides, and I get negative sine of x equals negative 1, or when is sine of x equal to positive 1? So let's see, when is sine of x equal to 1? X is y, so the only solution is pi over 2. So these are my three solutions to this equation using an identity. So keep in mind, we might have to use an identity whenever we have angle values that are different. So we saw that here, angle values that are different, or if we have functions that are different. So we had both cases here. So always look for your identities. We're going to see one more when we get to class in another day, but I'm going to have you try this checkpoint exercise at this time. Okay, give this equation a shot. Make sure to use identities and think carefully about what it takes to solve when you have a squared value and how zero product property can help you. But see if you can get this going. It does involve factoring, of course, as well as using identities. So bring your questions into class. We'll go over these the next day.